Hello and welcome to this video on solving equations containing rational expressions. This is the second part, the second video of two on this topic, where I'm going to be solving some equations involving, that contain fractions in them. And by solving equations, of course, we mean, I'm trying to find a value or values that I can replace a variable with, or variables, to make an equation a true statement, like 5 equals 5 or 10 equals 10, something that is clearly true. Okay, so let's do these couple examples. Got a few of them. First one, and I'm going through the same process that I went through in part 1, so if you haven't seen part 1, please maybe take a look at that, an example or two from that video. So I'm going to go through the same procedure in solving these equations. So first I have solved the rational equation. This equation with some fractions. You have 5 over z minus 4 plus 3 over z minus 2 equals z squared minus z minus 2 over z squared minus 6z plus 8. So the first thing I'm going to want to find is the least common denominator. Alright. So off to the side here, I'm going to put all the denominators, and we'll factor all the denominators completely. Alright, so the first denominator I'm seeing is the z minus 4. And z minus 4 is as factored as that gets. So I like to do this, put it in parentheses. This is the only factor, this whole thing, of z minus 4. The other one, next one, z minus 2. Same thing. This is as factored as this gets. You can't pull anything out of it. So z minus 2 is the only factor in the factorization of z minus 2. Finally, the third denominator I see, this z squared minus 6z plus 8. It's one of those, it's a quadratic, right? A degree 2 polynomial. And you can look up previous videos I've put up, or other videos from somewhere else, or look in your book on how to factor quadratics. I'm just going to jump into what the factorization is. Z squared minus 6z plus 8 factors to z minus 4 times z minus 2. And again, you can double check, distribute the z to the z minus 2, distribute the negative 4 to the z minus 2, and then combine like terms. You'll indeed get z squared minus 6z plus 8. Alright, so the least common denominator, or the least common multiple of the denominators, or the LCD, looking through the factorizations of the denominators, I'm seeing factors of z minus 2 show up, so there will be a z minus 2 to some power in the LCD's factorization. And I'm also seeing a factor, at least one factor of z minus 4 show up, right? So you'll have a factor of z minus 4 in the factorization of the LCD, and then the powers on these is the greatest number of times they show up in the factorizations of the denominators, right? So z minus 2 shows up 0 times, once, and once in these factorizations, and the largest of 0, 1, and 1 is 1. So that's z minus 2 the first, just z minus 2. And z minus 4, same thing, appears once, 0 times, and once again, and the largest of 1, 0, and 1 is 1. So the power on z minus 4 is the first power. Alright, so the least common denominator is this z minus 2 times z minus 4. If you want to multiply that out, fine, that's the z squared minus 6z plus 8. Great. Alright, then after that we were going to multiply both sides by the LCD. So I don't want the LCD to take on a value of 0, right? So the value of the least common denominator better not be 0. One, it's going to, it's made up of factors of other denominators, right? Remember, denominators can't be 0. Can't divide by 0, that's an undefined operation. So looking at the LCD, I see a factor of z minus 2, right? So the value of z cannot be positive 2. Also see this factor of z minus 4, so the value of z can't be positive 4 either. So I'm going to put this in a little bubble just to keep that in mind. So and you'll also notice that when z is 2 or 4, one of these denominators or more will be 0, and that's a problem. Alright, so as long as z is not 2 or 4, we can go on, we can continue. Alright, so the first part was finding the LCD. The second part was multiplying both sides by the LCD. So the left side here, there's two fractions, two terms, put in parentheses, you're multiplying that entire side by the LCD. So I've got the 5 over z minus 4 plus the 3 over the z minus 2, and that is getting multiplied by this LCD, right? The product of factors z minus 2 and z minus 4. Alright, and there's going to be some distributing going on here, again, because there's a sum here, multiple terms. That's the left side, equals. On the right side, I have the numerator, z squared minus z minus 2 over, and if you've seen other videos of mine where I'm dealing with fractions, right, whether it be adding or subtracting fractions or multiplying fractions, and even in part 1 of the video, the one before this on solving equations involving fractions, I like to have all my denominators completely factored until the very end. Just going to make things that much easier for you in the long run, I promise you. So instead of writing out the denominator z squared minus 6z plus 8, I'm going to write that in its factored form, which is the z minus 4 times z minus 2, or z minus 2 times z minus 4. Right. And again, that's the right side. We're going to multiply this by the LCD, z minus 2 times z minus 4, or again z minus 4 times z minus 2. Alright, now the whole purpose of this multiplication of both sides by the LCD is to get rid of the denominators, to kind of clean up the equation, make it look a little nicer. So let's work on the left side here. So I got to distribute. So when I take the LCD, these two factors, and multiply it by this fraction, you see I've got a factor of z minus 4 in the denominator, z minus 4 in the numerator, right? So this z minus 4 would cancel with this z minus 4, they divide out, and you'd be left with a factor of 5 and this factor of z minus 2. Alright, so I'd have 5 times the quantity z minus 2. Those two factors are left in that first term. Then plus, and then we're going to distribute, multiply the second fraction. So I got the plus, and then when I multiply this second fraction on the left side by the LCD, see the z minus 2 in the denominator, z minus 2 up here, they would cancel, and I'd be left with a factor of 3 times, and then this factor of z minus 4, the quantity z minus 4 would be left. Alright, so there's the new left side, and again, the only way I can do this is if the value of z ends up not being 2 or 4. Just keep that in mind. Equals, alright, and then on the right side, it's real nice. Right? When I multiply the fraction on the right side by the LCD, you see a factor of z minus 2 in the numerator and denominator, so those will cancel or divide out, become 1. And I see the z minus 4s as well. So everything's gone except for this numerator, the z squared minus z minus 2. Great. And now I'm going to solve this equation. And you might notice that this is, this is going to be a quadratic equation, right? Degree 2 equation. Your highest power of z is z squared. All right, so how did we go about doing that? All right, well, remember we tried to get, when you were solving a polynomial equation of degree, higher than 1, degree 2 or higher, was a good starting step to get everything to one side, 0 on the other, put it in what's called standard form. Alright, so let's simplify these sides first. Got a 5 to distribute here to the z minus 2. So that's 5 times z minus 10. And then I've got a positive 3 to distribute here to the z minus 4. So that's plus 3z. And then, minus 12. 3 times negative 4. The other side is still this z squared minus z minus 2. And then I'm going to simplify this side. So, combine some like terms here. Got a 5z and a 3z, making positive 8z. Got a negative 10 term plus a negative 12 term. Put those together, that's negative 22. Still have the z squared minus z minus 2 on the other side. Then we're going to I'm going to take everything to one side and have 0 on the other. Put it in what's called standard form. Now I like having a positive lead coefficient, a positive coefficient on my highest powered term of a polynomial. So I'm going to leave this z squared over here. So I'm going to take everything to the right. So I'm going to subtract the 8z from the left, and there's a negative 22 there. I'm going to add 22. Right? And what you do to one side, you have to do the other, right? So subtract 8z from the right side, and also add 22 to the right side. In combining like terms, I now have 0 on the left equal to z squared. Then negative z and minus 8z makes negative 9z. And then negative 2 plus 22 makes positive 20. Alright, so now it's in what's called standard form. Z squared plus negative 9z plus 20, everything on one side, 0 on the other. It's in descending order, highest power of z to the lowest power of z. And then we factor. Alright, or you could use the quadratic formula or completing the square if you want to look up other videos on those methods for solving a quadratic equation. But right now I'm going to go into solving this by factoring. So if I factor this quadratic over here, z squared minus 9z plus 20, that would factor to z minus 5 times z minus 4. Right. You can double check, distribute the z over the z minus 4, distribute the negative 5 over the z minus 4, and you'll get this back. And then we'll use something called the zero product property. All right. The only way here I have a product, right, a multiplication, a product equal to 0. The only way a product is going to be equal to 0 is if one of those factors is 0. So either the factor of z minus 5 is 0, or the factor of z minus 4 is equal to 0. And then so what we've basically done is taken, a degree 2 equation, a quadratic, and split it up into 2 degree 1 equations, or 2 linear equations. And you solve these. Here I would just simply add 5 to both sides. The value of z here, in this case, when z minus 5 is 0, z would be positive 5. Or, and the same thing here, I would just simply add 4. Z is positive 4. So here are the possible solutions to this equation. But don't forget, you must check your solutions. All right, check your solutions, which I'm going to do on the next page. Now one of these I see is going to be awful already because of what we said earlier. Remember earlier, talked about how I don't want to multiply both sides by 0, right, when I talked about the LCD not being 0. And we said that the value of z can't be 2, and it also can't be 4. I'll look at one of these possible solutions I got. Z equals 4. Well, earlier we said it can't be 4. So you're going to see in a second that this is no good. And they give a special name to that. It's called an extraneous solution. A solution that you find that doesn't actually work in the original equation. Alright, so let's do this on the next page. So let's check z equals 5. I'll start with that. Alright, so we're going back. Sorry about this. We're going back to the original equation. Alright, this is the way it originally looked. And I'm going to replace every z with 5. Alright, so the first fraction, you have 5 in the numerator, and the denominator would be, 1, right? 5 minus 4. So that's just 5 plus the second fraction, 3 in the numerator. The denominator, would be 5 minus 2, or 3. And then the right side, and bear with me, you got 5 squared is 25, minus, and then z replaced by 5, and then minus 2, and all that's in the numerator. And then the denominator, you got z squared, 5 squared is 25 again. Then minus 6 times 5, that'd be minus 30, and then plus 8. Alright. This left side, 5 divided by 1 is 5, plus 3 divided by 3 is 1. So on the left side I have 5 plus 1, which is 6. On the right side, the numerator, 25 minus 5 is 20, minus 2 is 18, and then 25 in the denominator, 25 minus 30 is negative 5, negative 5 plus 8 is 3, and 18 divided by 3 is indeed 6. We're getting 6 equals 6. Good, right? So z equals 5. The number 5 is a good solution to this equation. Right? I replace z with 5 and it works. We get 6 equals 6, a true statement. That's the other one. Right? Remember, I worked through this and I ended up with either z equals 5 or z equals 4. Now, again, I mentioned earlier z equals 4 is not going to be any good, but let's just verify that real quick right here. Let's check. Let's separate this here. Let's check z equals 4 now. Well, you'll see right away that it's no good. Right? When I replace z with 4, the first fraction is 5 in the numerator divided by, and then 4 minus 4, 0 in the denominator. And it doesn't really matter what happens the rest of the way, because that is no good. Right? Can't divide by 0. Can't have 0 in the denominator. Alright, so I'm going to scratch this off. Alright, that is not a solution. So what they would say is that z equals 4 is what they call an extraneous solution. Extraneous solution. Okay, meaning that it's a solution. It's a solution in quotes that you found in the problem, but it doesn't actually make the original statement true. And this actually happens quite often in problems where you get rid of denominators with variables, like we did, where because the original problem, z can't be 4, z can't be 2, right? Because I'd be dividing by 0. But then you see after I multiply by the LCD, look at the equation now. Now there's no denominators, and in this equation z could be anything, right? There are no denominators. So you kind of maybe invited in some numbers that you couldn't use in the beginning. You changed the domain of the problem, they would say. All right. So in cases like that where you eliminate variables and denominators, or get rid of them on both sides, you might have this case where you end up with a solution that doesn't actually work in the original problem, right? An extraneous solution. But we still have one good solution though, right? Great. This I worked through z equals 5 does work. All right, fantastic. Okay, so let's work that again. Here's another example. All right, solving an equation involving rational expressions. All right. So here I have 4 over, now the variable is y, and y plus 1 equals 7 over y minus 1 minus 8 over, y squared minus 1. Alright, so let's find the LCD, right, the least common denominator or least common multiple of the denominators. The first denominator, y plus 1, that's as factored as that's getting, so the only factor, I like to put it in parentheses if it's got multiple terms, is y plus 1. There's the factorization. Y minus 1, the next denominator, that can't be factored any further either, so its factorization, its only factor, is y minus 1. And then y squared minus 1, right, this is one of those difference of two squares, y squared minus 1 squared, and that would actually factor then to y plus 1 times y minus 1. Alright, so hopefully you're seeing, hopefully it's obvious that the LCD is going to have, y plus 1 to the first power, because it shows up on, the most times it shows up in any of these factorizations is once, times, and then y minus 1 to the first power. Again, the most times that y minus 1 shows up in any factorization is once. So really just y squared minus 1. If you say y squared minus 1, that wouldn't be wrong to say that that is the LCD as well. Alright, but I'm going to leave it, again, factored. I like having all my denominator stuff factored. And again, keep in mind that I'm going to be multiplying both sides by the LCD. We don't want the LCD to be 0 then, right? Because multiplying both sides of an equation by 0 does nothing for you. It just eliminates everything. You'd have 0 equals 0, and that doesn't give you any information about the value a variable needs to be to solve an equation. So we don't want the LCD to be 0, or any of these denominators to be 0, right? And I'm seeing a factor of y plus 1, so y cannot be negative 1. That'll make that factor 0. I see another factor of y minus 1, so y can't be positive 1 either. Again, keep that in mind as we go through. So these will make the LCD 0. These will make some of these denominators 0 as well back on the original problem, and that's no good. You can't divide by 0. Okay. So now comes the part where I multiply both sides by the LCD. So the left side just has a single fraction. It's this 4 over y plus 1, and it is being multiplied by the LCD. Right here it is in factored form, y plus 1 times y minus 1, okay, equals, and then the right side has a difference of two fractions, right? If you have a sum or a difference, we're doing both of those terms. I'm going to put this whole thing in parentheses. We're taking this 7 over y minus 1 and minus 8 over, and again, I like to have my denominators factored. So instead of writing y squared minus 1, I'm going to write y minus 1 times y plus 1, or y plus 1 times y minus 1, same thing. That's the same thing as y squared minus 1. So there's the right side, and it is being multiplied as well by the LCD, this y plus 1 times y minus 1. All right. So there's going to be some distributing involved because there are multiple terms. It's a difference. And again, like the first example, the whole reason for multiplying by this LCD is to eliminate denominators. So the left side, you see the factor of y plus 1 in the denominator here, y plus 1 in the numerator, so the y plus 1's would cancel, and I'd be left with a factor of 4 times a factor of the quantity, y minus 1. And there's the new left side. And then the right side, and we take the LCD and multiply, each of these fractions by the LCD. When I multiply the first fraction, this 7 over y minus 1 by the LCD, see the factor of y minus 1 in the denominator, y minus 1 here, those would cancel. I'd have, we've got a factor of 7 and a factor of y plus 1 left over. Right, the quantity y plus 1 would be left after the y minus 1's would cancel. Then we got minus, and then multiplying this second fraction by the LCD. Well, see how the LCD is that denominator. So y plus 1 would cancel and y minus 1 would cancel. All I'd be left with is that factor of 8. Right. And then here's our equation. and this is going to be end up, I don't see any y squareds. It looks like y the first is the highest power here. This is going to end up being a simple linear equation, right, where I get every term with the variable on one side and every term without the variable on the other, and solve for it. All right, so we'll do that. Let's solve for y here. So first I simplify everything, right? Get rid of the parentheses. We got distributing the 4 over the y minus 1 on the left side. So it'll be 4 times y, and then minus 4 equals. Then distributing the 7 over the y plus 1 on the other side. Then 7 times y plus 7. And then you got the minus 8 still. And before I move any terms to sides or whatever, I'm just going to totally simplify these sides. This side, no like terms, so that's still 4y minus 4. This side, there's only the one y term, 7y, but the plus 7 minus 8, those combine to make minus 1. All right. And as I've mentioned, I personally like having positive coefficients. So. What I'm going to do is I'm going to take all the y terms to the right. So I'm going to subtract 4y from both sides, making that positive 3y in a second. And then take all the constant terms, right, the terms without y, to the left side. So the negative 4, that'll stay where it is, and I just want the negative 1 gone from the right side. That's negative 1, so I would have to add 1, and I would then add 1 to the left side as well. So simplifying, got negative 4 plus 1, negative 3 equals, and then 7y minus 4y is 3y. And then to get y alone, right, 1y, not 3y, divide by 3, or multiply by a third, right, same thing. And I'm going to switch sides so that y is on the left now. So this side here, 3y divided by 3, that's y, equals, and then the other side, negative 3 divided by 3 is negative 1. All right. And then of course, that's only a possible solution. We must check back in the original equation. All right. Well, honestly, I don't really have to check, because I know from a statement we made earlier that in this problem, the value of y cannot be negative 1. And here I'm saying it is. Well, it can't be, right? I'll go back to the original problem. Let's actually check. All right, so here's the original equation. And when I plug in negative 1 for y, you see right away, the numerator is 4 in that fraction, and negative 1 plus 1, denominator 0. So it really doesn't matter what the rest of it looks like. So, if there is a denominator of 0 anywhere, that's no good. Right? That's undefined. You cannot divide by 0. So y equals negative 1 is not a solution. Eliminate that. This is an extraneous solution. Doesn't work in the original problem. So what do we say then about this equation? I tried solving it. I got what I thought was a solution, or what was a possible solution, and it ended up not working. Well, if everything I found doesn't work, well, that tells me only one thing, that this equation has no solution, and that is a possibility. Equations can have, no solution, one solution, 2, 3, infinitely many solutions. I mean, there are infinitely many possibilities to how many solutions an equation can have. But because my only choice, my only possibility didn't work, this equation has no solution. And that's fine. It's okay if an equation has no solution. That's still some information about it. And in some texts you might see this written out, where they write out the solution set of an equation. They'll have little curly brackets and then some numbers inside that make the equation true. Well, if it has no solution, sometimes you'll just see just an empty set of brackets. A set of brackets with braces with nothing inside. Or a little circle with a slash through it. And both of these symbols represent what's called the empty set. Both of these symbols, the little braces with nothing in it, or this little circle with a slash through it, represent what's called the empty set. That's just the set with nothing in it, no numbers, right? So this is just telling me that no numbers at all make this equation a true statement, right? In other words, the equation has no solution. Okay, so that's a possibility. All right, and then the last example I have for you is a little application problem. Right? You always come across word problems throughout books and backs of sections and exercises. Now this is going to be a particularly nice problem because we're given an equation that models the situation. We're given an equation for the situation described. That is not always the case. I will be putting out a video in the future where we have to solve word problems, application problems, where we have to set up our own equations with fractions. And those will be a little more involved. I think that's the hardest part sometimes is writing out your own equations based on information from a problem. All right, but here let's read through it. So this is the concentration C in milligrams per liter of a certain drug in a patient's bloodstream T hours after injection is given by this equation. Alright, so the equation's given, it's got a fraction in it, a rational expression. C again represents the concentration of a drug in a patient's blood at a certain point. T hours, right? T represents time in hours. C represents the concentration of the drug in the blood in milligrams per liter. T represents time in hours again, I said that. So the concentration C is equal to 50 times the time divided by the time squared, T squared, plus 25. Alright, then the question is, when will the concentration of the drug be 4 milligrams per liter? All right. So the big question here is, see how they're asking when? When means when is a question of time. So we're going to be solving for time here. Right? We're going to have to find a time, and then this 4 milligrams per liter. They told us that was the concentration, right? So this 4 milligrams per liter is the value of C, right? The concentration. So what I'm doing here is just going through the equation they gave me for the situation. The concentration of this drug in a person's blood at any given time, T hours later. And I'm going to be replacing C with the number 4, right? Because again, C was given in milligrams per liter, and they said the concentration here is 4 milligrams per liter. So I'm going to be replacing C with 4, and then figuring out when does that happen, right? Solving for T, solving for time. So in doing that, we have this equation right here. So C is replaced with 4, 4 on the left side, equals right side, 50t. We don't know t yet, right? We're trying to find t. We're trying to find when over the t squared. Again, I don't know t, right? Over the t squared plus 25. Right, and then we're doing exactly what I set up here. We're looking at this equation and solving for t. And then we're going to state what that means in the end. Remember, t represents the number of hours after the injection of the drug. Okay, so it's an equation with fractions. So looking for the LCD. Now, t squared plus 25 is the only denominator. And it's a sum of squares. You can't factor a sum of squares over the integers. And I say over the integers, meaning you could factor this over what are called the imaginary numbers. I haven't really gotten into that too much in other videos, but if you're familiar with imaginary numbers, great. If not, look them up, find some videos on imaginary numbers. Maybe that'll make more sense what I'm saying. But the only denominator here is t squared plus 25. Yes, you could always throw 4 over 1 and say that it has a denominator of 1, but the LCD is, the only denominator here. All right. And remember, as I've been saying, we don't want the LCD to be equal to 0. Right? So when is t squared plus 25? When is that equal to 0? Well, that's going to be equal to 0 when t squared is equal to negative 25. And, this can't happen. Right? This happen with the real numbers. They would say that t equals, either the positive or negative square root of negative 25. And again, those of you familiar with imaginaries, this would be positive or negative 5 times I. Right? I times the square root of 25, I times 5. I is that imaginary unit. I is called, representing the square root of negative 1 here. But these are not real times, all these here. These are what they call imaginary numbers. So the least common denominator, this t squared plus 25, will never be 0 for a real number, only for imaginary. So we don't have to worry about it. We don't have to worry about the value of the denominator being 0 ever. Okay? Because we're only dealing with real time. Right? All my times are going to be in real numbers. Okay, so the LCD is t squared plus 25. It's never going to be 0. All right, not real. So this guy here is not happening. All right. And then we go through and solve the way I've been solving. Right? These equations with fractions. So I multiply both sides by this LCD, by the only denominator. All right, so the left side is 4. And it's getting multiplied by, now you're multiplying again, but technically remember this whole thing is that's the only factor that, so I put in parentheses that is the factorization of the LCD. So I'm multiplying by the whole thing, the quantity, t squared plus 25. And then the right side, right, I've got 50t over t squared plus 25, and I'm again multiplying this by the LCD. The only factor is t squared plus 25. And hopefully you're seeing again that all this is its own factor. That's as factored as that gets. So the factor of t squared plus 25 there in the denominator, and a factor of t squared plus 25 in the numerator. So all I'm left with on the right side is 50t. And then on the left side, right, I want to simplify that a bit and distribute the 4. At 4 times t squared plus 100, right, is equal to 50t. And then we try solving this, and this is another one of those quadratic equations, right? Degree 2, the highest power of t is squared. So I do what I did with a quadratic earlier in the video, get it in standard form. I'm going to take everything to one side. So take away, I'll leave the positive 4t squared and the 100 over there. I'll take away 50t from both sides, and then write it in standard form. So that's where the polynomial is in descending order, and then 0 on the other side. So I have 4t squared, then the negative 50t, and then the positive 100 term. And this is equal to 0. And then we try factoring this thing. Right? Now if you look at all three terms, right, the greatest common factor, the number that goes into all these evenly, is 2. So I could factor a 2 out right now. And if I remove a 2, what's left is 2t squared minus 25t, and then plus 50. All right, and again, this is a product equal to 0. And then you keep going. I can probably factor this one. Now this is one of those quadratics where the lead is not 1. So if you again go to another video where I factor this by grouping, you would take the lead coefficient 2 times the constant 50. 2 times 50 is 100. And then think of factors of 100 that add up to negative 25, and that'd be negative 5 and negative 20. Then rewrite the middle term and then factor by grouping and so on. But I'm just going to skip to the end where we get the factors. Alright, so you got the factor of 2 pulled out earlier, and then you're going to have one factor where 2t is first, and then the other one's going to have positive 1t, so that way you get your 2t squared. And then the factors of 50 that I need so that when I FOIL I get negative 25t. Let's see, I would need negative 10 here and negative 5 there, right? Because that gives me negative 20t, then negative 5t with the inners, and making negative 25t, and then you get your positive 50 when you take negative 5 times negative 10. Alright, so this product is equal to 0. And then the only way that a product is equal to 0 is when one of the factors is 0. So either 2 equals 0, but that's not true, right? That'll never happen. So I don't have to worry about that factor giving us that information. It's really only the factors of variables that could possibly be 0. Or 2t minus 5 equals 0, or the factor t minus 10 equals 0. Pardon me. And solving each of these, we get here t equals, I would add 5 divided by 2. 5 divided by 2, 5 halves, or if you want to write this as 2.5 or 2.5, same thing. Or, and then here adding 10 to both sides, t equals 10. Okay, and then and you could double check these, right? Now, when I check them, I'm going to check these on the next page. Not check. Alright, so I check these back in the original equation, right, which was this guy way back up here, right, when I replaced the concentration with 4. So this 4 equals 50t over t squared plus 25. So let's check. The first one was t equals 5 halves, right, or 2.5. Alright, so the left side's 4 all the time. Now the numerator, you have 50 times 5 halves, or 2.5 times 50. That'd be 75. Alright, I'm sorry, not 75, 125. Alright, because 2 goes into 50 25 times, and then you'd have 25 times 5. So you have 125 in the numerator. And then in the denominator, 5 halves squared would be 5 halves times 5 halves. That's 25 fourths. And then plus 25. All right, and then we have what's called a complex fraction. And I've put up videos simplifying complex fractions if you want to look at that. But this is 4. Then this has a numerator of 125. And then there's the main division bar. And then 25 fourths plus 25. I would multiply this fraction. Think of this as 25 over 1. You can't add these right now. You need a common denominator. So I'd multiply by 4 over 4. And that would give me, 25 plus 100. Right? 4 times 25. So 125 over 4. Right? The common denominator before. And when you add or subtract and you have a common denominator, that denominator stays. And then, 125 divided by 125 over 4 is the same thing as 125 times the reciprocal, 4 over 125. and the 125s would cancel, and I am indeed getting 4 equals 4. So that is a good solution, right, to the equation. Now we're also going to have to think about, does this make sense with the problem, right? We'll talk about that in a second. All right, so then the other one's t equals 10. Right, the other possible solution I found was t equals 10, right there. Plug in 10. So the left side was 4. Let's separate this. So the left side's 4. There's the original. The right side. Numerator 50 times 10 would be 500. Denominator 10 squared is 100 plus 25. And this is 500 in the numerator divided by 125 in the denominator. And yes, 500 divided by 125 is 4. You get 4 equals 4. So this particular equation actually does have two good solutions, 5 halves and 10. All right. Now let's think about what this means, right? So this means that the concentration in milligrams per liter, is the concentration of the drug in a person's blood would be 4 milligrams per liter, 2.5 hours, remember T represented time in hours after the injection, or also 10 hours after the injection. It's an interesting one. How would I have a concentration of 4 milligrams per liter at these two different times? Well, one thing we could do is make a graph. All right, let me show. So yeah, we could look at a graph of this particular function. All right, and I'll make a little table, not table here. I'll make a set of axes. All right, where I'll have the horizontal axis be the time in hours, right? And the vertical axis be the concentration, and that was the concentration in it said what, milligrams per liter, right? So mg per L, right, milligrams per liter. Now the function, right, was this. It was the concentration. The equation they gave us was this. The concentration is 50 times the time divided by the time squared plus 25. Right. Now you could go and try to make a table and stuff, like, plug in values of t, plug in different values of t and see what values of c you get. And I'll make a little table here, a little chart. So like an easy one would be if t were 0, you'd have 50 times 0, you'd have 0 in the numerator, and then 25, 0 squared plus 25 in the denominator. That'd be 0. 0 divided by 25 is just 0. Alright, so a point on this plane is 0 for t, 0 for c. And we've seen a couple now already, right? Now, with our equation solving, we have seen that after 2.5 hours, right, after 5 halves hours, the concentration is 4, right? As we set C to be 4 back in our equation. Also, we saw that 10 also works in making the concentration 4. So I'll plot those. So let's say this is 1 unit here, 1 hour, 2 hours, 3 hours. And let's say that's 10 hours out here. Right? And for the concentration, say that's 1 milligram per liter, 2, 3, 4, 5. It might get higher. but at 2.5, right? 2.5, 5 halves is right here between 2 and 3. So at 2.5 hours, the concentration is 4 milligrams per liter. So there's a point on my graph. And then at 10 hours, the concentration is 4 milligrams per liter. And what kind of graph is this? Now you could go through and plot a whole bunch of other points, but I'm going to go to my handy dandy calculator here. I've got a graphing calculator here to show you. All right, let's get it out of the way of the camera there. And notice I've already punched in the function here. Y equals 50x, where y is going to be the concentration, x is the time. So that's 50x in the numerator, and then divided by, and then in parentheses, x squared plus 25. That's like 50t divided by t squared plus 25. And look at the graph of this thing. All right. So it starts off at the 0, 0 point, like I said there, where the two axes cross, and then it climbs a bit, and then starts coming downward. So it looks like it's doing a little bit of this, and the peak of that hill there. There's 2 and 3. 2.5 is between there. The peak of that hill is a little after this, so it looks like it's doing something like this. Climbs, 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 and then starts falling, very, very slowly, and keeps falling. All right. So, and again, I'm only focusing. Notice I'm only focusing on the right half where time is positive, because we're talking about time since an injection, so there's no need to look at negative time. The time before the injection, you had none of the drug in you. All right, so let's look at which answer makes more sense, if not both of them. So remember back to the original problem, the C is the concentration in milligrams per liter of this drug in a patient's bloodstream, T hours after injection. Is given. All right, so this is kind of weird, right? It's perhaps the problem of the example I looked at. I honestly just pulled this from some book somewhere. Just gave us an equation just so we could practice solving equations. Because all right, so yeah, I get it. 0 hours. This is, you haven't had the injection yet. But I would be thinking that as soon as you got the injection, the majority of the blood is in your bloodstream. You'd have the majority of the drug in your bloodstream. It would be at a peak, and then start to fall slowly. I don't think that the amount of drug, or maybe this makes sense where you inject. I'm not a doctor or a scientist. It's probably obvious after watching a few of my videos. Or maybe after the injection, you inject it in your arm or something. It takes a little bit to get to your pump around in your body, get to your heart. So after a couple hours, it slowly climbs, and then it's at 4 milligrams per liter here, and then it's it finally reaches your heart, and then it pumps it around. So it's definitely in your blood more or something. I don't know. I really honestly don't know how blood, drug diffusion through your blood works. And then it peaks, and then after time it gets lost through maybe waste product or sweat, or I honestly do not know. But then maybe it decreases over time, and then at some point later on it's back down to 4 milligrams per liter of your blood. All right, so if this graph actually is the way blood, a drug diffuses through a patient's bloodstream, then we have 2 legitimate answers. Okay, so my answer then finally for all this, looking at this graph, or just realizing that I had 2 good solutions to this equation, right? This equation we set up when the concentration was 4. We had 2 valid solutions, 2 positive times, 2.5 hours and 10 hours later. So my answer then will be the concentration of the drug will be 4, I'll just put milligrams per liter like this, mg per over L, right, milligrams per liter. 5 halves hours, right? We have t equals 5 halves, or 2.5 hours, and 10 hours after the injection, because both of those worked in my equation. And again, I don't have enough of an understanding of the science to dispute this graph, right? Again, I pulled this problem from a book. This equation is just thrown at me, so I have no reason to dispute this. So based on the information I'm given, here's how I'm going to answer this question. All right, so when will the concentration of the drug be 4 milligrams per liter? It'll be 4 milligrams per liter, 2.5 hours after the injection, and also, when it starts coming down, 10 hours after the injection as well. All right, so sorry about, that might have been a bit confusing there, but the key to take away from this is, again, how to solve these equations. All right, and if you want to go into, physiology, biological sciences, learn more about how drugs diffuse through a bloodstream, be my guest. I apologize that I have not done that in my life. But the key here is to understand what they're asking for and how to solve one of these equations with a rational expression in it. And then, of course, word problems. You should be answering word problems in a full sentence, complete sentences, to actually answer the questions that are being posed. Okay. So hopefully you got something out of this. Solving rational equations. Find the LCD. Make sure it's not 0 ever. Determine values of the variables that'll make you divide by 0 or multiply both sides by 0, because those can't be used. Multiply both sides by the LCD. Solve the resulting equation, and of course, probably the most important thing is to check your solutions. Make sure that they work in the original equation, and if they don't, remember, those are called extraneous solutions, and they can pop up here and there. Alright, as always at the end of these, I like to say, please, try your best to understand and get the material before you go out looking for help, because I find that people, people tend to remember things better. It tends to stick with people better once they've put in the hard work and put in the effort to learn things on their own. So read through the authors, read through the material, read through the author's examples, perhaps even try to work out the solutions to an author's example before you read how the author did it. See how that goes. See what you can learn from there. Practice problems, of course. Look for problems that have solutions provided, preferably, so you can actually check how you're doing at the time you're working on them. And don't give up after the first attempt. All right? Don't just give up right away. Don't get frustrated so easily. Keep practicing. Keep trying. And if after several attempts at a problem it's still not clicking, then perhaps you should read the material again. Maybe a little more slowly and carefully this time. Maybe even a third time. And that second or third read through, you might see something might click that didn't click, or you didn't notice the first time through, and it'll help. But if after several read-throughs of the material and several attempts at a problem, you're still not getting it, something's still not clicking, it is not a sign of weakness whatsoever. Not at all. To go out looking for help. That is what other people are there for. Alright, so ask a teacher, ask a tutor, a friend, someone in the class who knows the material well. Look for online materials, supplemental materials online, videos, maybe videos such as this one, or videos out there that are plenty better than this one. I promise you they're out there. And just keep at it. Stay persistent. Keep practicing, and just keep at it. Don't give up, and I know you'll eventually get it. And try to stay positive. Too many people I know, go into a math class, go into their homework thinking, I hate this, I hate this, I hate this, I hate math, I've always hated math, well, guess what happens when you say that over and over again? You're going to hate it. All right, it's amazing. You'll be amazed at the difference when you just change your mindset. And that's a hard thing to do, I understand. Right? You can't just flip a switch. But if you try to go in with an open mind, thinking I'm going to learn something here, I'm going to take something positive out of this, I'm going to enjoy this, have fun with this, you just might. And it'll make all the difference in learning the material. Alright, so keep at it, keep practicing, try to have fun with it, and thank you for watching.